To demonstrate what happens when you don't apply indexes on your MongoDB, I have created an application here which is a simple Node.js application using Express, and that is going to display us the information about various business listings. As I have mentioned this example before, these listings are grouped into certain categories that we can see here, and if we click on any of the category, what we can see is we'll be able to see all the listings sorted by name from that category, and these are just randomly generated listings. You can even do pagination on them, you can do sorting on them as well, right? As you can see here, the performance of the application is not that great. I'm almost having a lag of 2 or 3 seconds between my actions and my response. To verify that, if I show you the log of Express, you can see that all the actions are almost like in 3 to 3.8 seconds. And why is that? Because my MongoDB has around 2 million listings. So to verify that, I can do mongodb.listings.count, and that's gonna return me 2 million. Okay, and that's why my queries are taking a long time to respond. Now 2 million is not such a big number, so how can I improve the performance when my application's data grows beyond billions or even just millions? As we can see that even with the 2 million, we are seeing the delay of almost 3 seconds. So to fix that, we can apply indexes on our collections. That's gonna help us to improve the performance. Now let's see what are the indexes and where they can help me. So I need indexes so that I can do faster reads, I can do faster updates, because for doing any update you have to first find that record, right? And similar thing is with the deletes. Similarly, I can use indexes to maintain certain constraints on my documents. Like if I want to make a particular key is unique across the collection, I can use unique index to do that. Indexes can help us to improve sharding as well. Sharding works on a sharding key, and that sharding key, if it is properly indexed, will help you in faster sharding. Indexes can help us in sorting as well. We can see that in example of how each of the scenario will be affected if we use indexes. Now how to create an index. So to create an index, you can use ensure index command on collections with a document which will tell us that we want to apply index on the given key. So here in this example, you can see that I am creating an index on key title in the ascending order on the movies collection. If you want to do the same thing in my current schema of the listing, I will do that db dot listings dot ensure index on category. Correct? And now when I hit this command, it's gonna take some time to get the index. It's gonna assign an index key to each of the document and going to store the index in a sorted order in the memory of my computer. So that's why it will take some amount of time. While it is doing that, what we can do is I can show you. Oh, it's done. So now as index is created, let's see if is better or not. So let me go to the application, let me go to categories, and let's say I want all the listings for hotel category, and you see it's pretty quick. I go back and I click here and I'm getting results pretty fast. Let's see the amount of time it is taken. It's now taking only around 1 second to return that result. So that means just by adding the index we have improved the performance of our application by threefold. Initially it was taking around 3.5 seconds, now it is taking almost 1 second. Now how will you know that we have created the indexes? So to see whether the index has been created or not, you can use the get index command on a collection. That's gonna give you all the indexes on that collection. So let's see that. So let's say db dot listings dot get indexes, and you can see here I have two indexes. One index which is created by MongoDB by default on the underscore ID field, and the second index which we created on category. That way we can see all the indexes on our collection. Now if you don't want a certain index, what will you do? You can delete that index, just as you can delete any other document in the collection. To delete the index, you can fire the drop index command on the collection by specifying the document which was used to create the index. Now how can we be sure that all my queries are using indexes? So MongoDB shell provides a very good command called as explain on any cursor that will tell us how that cursor is utilizing any index, or if it is not, then we can use the explain to discover indexes that we might want to create in our database. So let's say an example of this. Now how can I be sure that my queries are using the newly created index? So what I'll do is I will say I want to find all the listings with category sports. Okay, and I want to do explain. Let's see. So we got some result here which says that it used the cursor, which is a B tree cursor, because indexes are stored in the form of binary tree in MongoDB. It is going to use the binary tree cursor if it is using any indexes. So we can see that it is using this category underscore 1 index, which we can see here, that was created in earlier command when we use ensure index. And you can get lot more information with this explain command. It also tells us that by following this cursor, how many objects did it scan to return the result. So we can see that it did not scan all 2 million documents. It scanned only 250,000 documents, because this category had these many indexes, these many documents associated with sports category. Let's say if we don't have any index, what's gonna happen in that case? So let's say I want to find something with the title S, and there is no index on that title. What do you think? What's gonna be the result? Or let's find another query. I want to get all the listings where average rating is greater than 4, and let's see how much time does it take and is it using any index or not. So you can see that it did not use any index here, as it is telling that it used the basic cursor. That means because there is no index on the average rating field, it went through all the documents and checked if the average rating is greater than 4 or not. And that's why we can see here that it scanned 2 million records and it found 29,000 such listings which have average rating greater than 4. But the significant difference that you will find here that it went through all the 2 million records, and here in this case it went through only the records for which there was an index. The explain query can also tell you about the amount of time it consumed. So in this previous query you can see that it consumed only 784 milliseconds, and here it took almost 2 seconds. So that was about explain. This way you can be 100% sure that your indexes are being used the way you want them. Now while creating an index you can specify many options, such as if you want to sort a particular index in an ascending order or a descending order. Although it doesn't really matter, because MongoDB optimizes indexes in such a way that it can even traverse the binary tree in a reverse direction. So it's gonna take same amount of time to find the record starting with A or the record which starts with C. You can use unique option to specify if this index is unique or not. This is another way to maintain the uniqueness of certain key in the collection. Let's take an example of this. Let's say I'm connecting to an ExpertTalks database. Yeah, and let's say I have a collection called movies. Okay, let me insert a new document with the name with title matrix. But I want all movies to have a different title. So what I would do is I will create a unique index on title for movies collection. So in ensure index I'm gonna use title as my key, and the option for index creation will be unique, and I want it to be true. Okay, let's be sure that the index is created. Let's see, index get indexes command. Oops. So we can see that we have created a new unique index with this unique attribute set to true. So now what will happen if I try to insert a new record with the same title? Let's try that. Let's say I'll do db dot, I'm going to insert the same record with the title matrix, and you will get an error that you cannot insert a duplicate key in the index. And that's how I can achieve the uniqueness of certain key in my collection. Pretty useful, isn't it? Now you will ask me what will happen if there are already records in the collection with the duplicate data. It's certainly a right question, and you can use drop tupes command to drop all such duplicate records. But you have to be very careful while using this command, as you cannot tell which records will be deleted and which will be kept by which MongoDB will keep in the collection. Let's take an example of this as well. So let me delete this index that we just created. Drop indexes. Okay, it tells me that I was able to delete the index. And now let me try to insert another document with the same name with some more information in it. See, I was able to insert a new document with the same title. Let me insert another document. I was able to insert that as well. Now if I do find on movies collection, I will see that I have 3 records with the same title but different attributes. Now what will happen if I do ensure index here with unique is equal to true? Here you will get an error as there is already a duplicate record, right? That means I cannot create an index until I specify remove dupes over here. So let me set that option as well, and let's see what happens. Index got created, but now if I do find on the movies collection, you will see that I did not have any control on which records will the drop dupes keep, and only the first record was kept by MongoDB index creation, and other 2 records were deleted, and that way I lost my data related to the year in the movies collection. And this is the reason that you have to be very cautious while using drop tupes. After drop tupes, what's gonna happen if the key is not present in some of the collection? You can tell MongoDB to ignore such records from indexing. That means those records won't be considered while you are creating an index. Let's see an example of this and when we'll use this. Let's say I want to add some records here. With year, and let me add some more records. Okay, now if I do find on my movies collection, I will see that I have 4 records with different title, and some of them have year and some of them don't. Now what's gonna happen if I create index on year? Let me create index on year. Now you will see that the index has been created. Okay, now if I do find on movies and I want them to be sorted by year, interesting. I get the records for which the year is null before the records where there is an year. This is kind of an unexpected result. This happened because MongoDB, when tried to create an index on year, it finds some of the records for which there was no index, and that's why it assigned a null value to that index and stored it into the index tree. So let me drop that index and create that again. Okay, index was now deleted, and while creating an index, let me specify an option for sparse index. This way you can see that now if I do find and sort by year, I will only get the records for which there is an index of year. Parse is more useful when you have millions of records and only some of the records contain that sparse field, that index field, and that's when you want to use parse. You don't want to look through all the 2 million records for documents which does not even contain that field. So let's go back and see what's next in the index creation options. Next thing is named index. Now as you have seen that by default MongoDB gives a name to an index. You can override that default name by specifying a name to certain index. So if we go to our collection and see what are the indexes, you can see that MongoDB is using a convention like the key and the order in which the index is created to create the name for that index. But I can certainly write any name for this kind of an index. So let's say I draw the index on title as well as year. And I create index again. I can specify an index creation option for year with some name associated with it. Let's say I want to name my index as release year. And then if I do the get indexes, I can see that my index is now using the name whatever I gave in the index creation options. This is very useful when your indexes become very complex and they don't really know what exactly is happening and what is the purpose of those indexes.